This is my presentation on using Geodatabase techniques to remove unwanted data from sets. The online survey is an amazing tool. It has many advantages and very few disadvantages, some of which include being able to gather surveys from large numbers of people that you don't have to directly interact with, the survey data collected and stored in the software itself in a uniform way that reduces some human error. And you don't have to have the participants in one place in order for them to take the survey. These advantages can become disadvantages if your survey has an incentive. Surveys with incentives can gather malicious parties trying to take the incentive offered even if it's not deserved. This happened to the survey that we will be looking at in this project. The objective of this project is to create a database for the responses of a human subject survey to manage the collected data and to identify the responses suitable for analysis of the questions in the survey. This is important because some of the data was generated by bots from the malicious parties, and these will not be considered for the analysis. The data collected was from September 1st through November 30th for volunteers who are willing to participate in a post-disaster mental health survey. Data was collected in two forms. The first was from the respondents themselves. These are direct answers to the questions posed in the survey, and that includes things like demographics, mental health, and influences on their mental health. The other part of the data is collected from Qualtrics, which is the software that hosts the survey. This is information like how, when, and where the respondent took the survey itself. Did they take it in English? How long did it take? What time did they start it? Because this data is coming from a survey that was attacked by a bot not once but twice, the survey itself is split into three versions. Version 1 from September through October 20th was the victim of the first bot attack, and it was paused midway through a surveying event. Version 2 is identical to version 1 in every way except that the reCAPTCHA data is a bit more robust since there is the reCAPTCHA out front protecting it. However, there was a 4-day attack on version 2, and as such it was paused, and version 3 was created identical to version 2 with the reCAPTCHA. However, now it has a single added question to the beginning to ask the respondent directly, where were you and who asked you to take the survey? The first step in this project is to plan. Because there's 3 different surveys and they are all slightly different, all of the fields needed to be matched up so that as the data is sorted through, it can all be put exactly where it needs to be. So if you look at the image, you can see that there is a lot of fields. This is a long survey. The first 2 of each row is for the fall survey, which is version 1, post is version 2, and Nov is version 3. Then below is the type of data collected. This will be important for making the geodatabase and whether or not it can accept null data or should accept null data. And the third question I posed for each field is, will it help in the bot test? This first orange square at the top is Qualtrics related data that will make an impact. So you can see that the end date and the IP address will have some impact on whether or not it is a human or a bot. Likewise, in this orange box are questions that are from the human responses that are likely to determine whether or not they're a human or bot. Questions that aren't likely to be participating in the bot test are questions that are easily just clicked on, and it will be indiscernible either way if you are a human or a bot. So the first thing I did was I went to ArcGIS Pro and I created a geodatabase. Then I established a study area. This is really for my reference and for later mapping, but it was part of the process. The study area is Nueces County with about a 50-mile buffer from the surrounding communities. The people who live and work there often come to Nueces County for meeting their needs, whether it's entertainment or healthcare or just family. And so they are a part of the larger community, even if they don't live within the county itself. Next, I added the scattered tables to the geodatabase using the Table to Geodatabase tool. Now that all the fields have been lined up, they are ready to be merged with the Merge tool, and all the data is matching. From there, I used the longitude and latitude collected by Qualtrics to plot points with the Table to XY tool. This isn't an identifier of whether or not the human or a robot took the survey, but rather it gives me an idea of where the data is coming from according to the devices that it was taken on. And so there were some devices that were human and confirmed human that recorded places that weren't in Corpus Christi when the survey was taken. However, it could be because the device's location was set somewhere else or it was turned off altogether. That being said, most of these were within the United States, and most of the bots were not necessarily as uniform as the human surveys, and this can be seen later. Next, I moved to PostgreSQL. I had downloaded or exported the shapefile made by the points being plotted, and I kept the attributes that would be helpful in taking the bot test. With this information, I created a database, and then I created a table from the shapefile. Then I made a query to take the shapefile apart and start locating the candidates that could be human, or rather are human, and could be a part of the analysis. This is the first query I did. Create table. I selected all of the fields from the original table. The original table was responses with bots. And then the duration is one of the measures I decided to use to immediately knock out some of the robots. This is 5 minutes. I think only one human did it in less than 5 minutes, and so unfortunately they are not a part of this. However, this is really just a test to see how well this process works. And so despite my mistake in using 5 minutes as a metric, any survey that took less than 5 minutes was excluded from the data at this point. I then proceeded to start choosing other bot tests that could help identify who is a human and who is not. So the next one I did was location. I looked at the longitude and latitude, and I determined that every human was a part of the continuous 48 states of the United States, and the only responses that came from Alaska and Hawaii were on bot attack days. Therefore, they're more likely to be bots. So I drew a border around the continuous US from the northernmost longitude and latitude, and then I excluded all points that were not within these bounds. And that's what you see here. The points were deleted and then verified that the deleted points were indeed gone. And normally I wouldn't simply delete data. However, this database file is a copy of a copy of a copy. And so if I needed to correct my mistake, like I will have to with the 5-minute duration, then I can simply go back and add those attributes back in. I also did this for the longitude and for the recaptcha score. The recaptcha score is basically a test the Qualtrics did to see whether or not their algorithm believed a robot or a human was taking this test. And the metric was 0.5. So on a scale from 0 to 1, if you are above 0.5, then you are more likely to be a human. So anybody with a recaptcha score below 0.5 is definitely a robot. Now for the results. This is a map of all the responses that were collected for this project. You can see the Alaska and the Hawaii was there, however those were indeed bots. And there are quite a few responses from other countries, however these were also bots as well. After all of the points were sorted out, this is a map of the United States with respondents that we found to be humans. These are not necessarily all of the responses that will be used in the later analysis. However, it is at least able to see who is within the survey area and who is not. The survey area is marked in yellow. The project, I believed, went well. It was able to sort out a lot of data much quicker than it would be by hand. However, some of the downfalls that I found in doing this project were that the amount of precision needed for some of the attribute fields to be properly useful in determining whether or not you were a human or not a human was not easily obtained in either Postgres or ArcGIS. For example, the start and end date and time are really, really precise. And so as a human, I'm able to see exactly what time somebody started and what time somebody ended. And any response that was exactly the same start and end time was definitely going to be a bot, because a human would not have been able to look into that if they tried. And the techniques I used today were not rigorous enough to determine this on their own. And so markers like the start and end time that had to be used together were not accounted for here. And so it would have taken more steps to identify even more bots. Also, some of the markers of being human are just errors that a robot would not have made. For example, Americans, when they're writing their address, do not include the country in their mailing address. This is part of our culture. Most Americans aren't even aware that other countries have to write their country after they write their mailing address. And so every time you see a mailing address listed, one, it was less likely to be a human already, but if it said USA at the end of it, it was definitely a robot. There's also the case of humans writing in response to the question, how many people live here? They wrote their mailing address again, which is not the answer, but not a single robot did that. And so it's easy to find those human errors, but it's not as easily told to the computer, please keep this one. I understand it's wrong. At the very least, this process was quite efficient for removing a lot of data that was made by robots, which is important when you're dealing with robot entries in the thousands. And now all of the information is tidy and in a database, and so it's easily accessible, easily retrievable, and easily sorted and organized to continue looking for false entries. This concludes the presentation. Thank you so much for watching.